Welcome to Matrickz Tech Talk. In this episode, Alex Polonsky talks about his Detroit Autonomous Vehicle Group initiative. In this episode, we have Alex from Abraham Hill, Michigan. He works for a German company, Brose. He is a passionate technologist. His mission is to impact the world in a positive way with technology. Alex, welcome to Matrickz virtually.
Hello. Thank you for having me, Dr. Hassan. It's a pleasure to be here.
All right, Alex, why don't you tell us a little bit about yourself, about your passion?
Sure. So I was born in St. Petersburg, Russia, and then when I was 12 years old, we moved to San Francisco, Bay, California. Then I was raised there, and then that was in 1994, and then in 2011, I followed my passion for automobile and moved to Detroit. And things got really tough, and I think for most of the world around 2007, 2008. And so at that time, the automotive industry I graduated college in 2007, which was a pretty bad time to graduate and try to get a job. And I ended up actually getting an internship at NASA, and then I worked at NASA, and in 2011, things began to pick up. And then I was around 20, 29 years old, and I figured if it's not now, then I don't know when. Pretty much left everything and quit NASA, left my friends and family, and moved to Detroit, Michigan to try to see if I could get into the automotive space and pursue my passion. I've been passionate about automobiles my whole entire life, and that spans from I don't know when I got into automotive, but I followed Formula One as a kid. I did motorsports. I built race cars. I raced cars for a while. Then I worked on some racing teams such as Flying Lizard Motorsports out of California, which won multiple championships. And so I just really wanted to have some sort of an impact through transportation and mobility. And in 2016, when Udacity announced the self-driving car nano degree program, my brother, who's still out in the Bay Area, he sent me a link to it, and he thought that would be a great fit. And I enrolled in it, and naturally, it was a great fit. I was always into automotive, and I was always into cars, and then inevitably technology also. And my dad is a software developer, so I've always been around computers. And by trade, I'm not a software developer, but I think in today's day and age, it's very hard to not do any software and be in technology. And so when you bring the technology and software development and automotive together, you basically get a self-driving car. And so the program, I was really interested in this, but there was no way to get into it. And when this program came about, I was really excited about it, and I enrolled. And shortly thereafter, I began to see how complicated and how difficult it is to make a car drive itself, and how many different disciplines of engineering are involved. So I wanted to take that knowledge, and then also Udacity's the self-driving car nano degree program. It's mostly in virtual spaces, especially back then. It was all in virtual space. So you use Jupyter Notebook, and you run your scripts there, and then you test everything. But I wanted to bridge the gap between the virtual world and the physical world, and also there's no way you can understand all of it by yourself. And also, I'm a better learner when I have somebody to learn with. So I started this group, and with some of Udacity's help, they pointed me to how to start something like this locally. And I started a meetup in February of 2000. Now it's 16. So 17, February 2017. So it'll be 2 years soon. And ever since then, we started building trying to develop technology on a scale. So we went to a local electronics store. We bought a remote control car for about $40, and we started porting it. So cut a hole in it, put a Raspberry Pi in it, put a camera on it, and then we started trying to take that knowledge that we were getting through the self-driving car nano degree program, and also we became the Detroit chapter of the DIY RoboCar community, which is run out of the Bay Area, and they have some working cars, and so some of Some of them we picked up along the way, and then we've made them work. And we also found out how difficult it is to take the code that's developed in virtual space and then really port it on a much smaller computer. But also in that challenge, we're forced to figure out more efficient ways to write software, more efficient ways to do things. I mean, our software and our cars are a lot smaller, so the complexity is less, but the principles are all the same. The foundation is very, very similar to what you will find on a self-driving car. Only we don't have to go and buy, pay $300,000 or $400,000 for a equipped test vehicle for a self-driving car. We can go get an RC car, put a small LiDAR on it, put a small camera such as the OpenMV, and then we can try to develop very similar technologies on our own and not break the bank, so to speak. So that's how our group came about, and that's what our group is currently doing. The mission with the group is to try to democratize technology and at the same time try to build a community around it, or trying to do that through building a community. And also, Detroit really needed something like this, where Silicon Valley is all about automation. I grew up there. I understand Silicon Valley pretty well, and so even though I moved from there, but I think that Detroit is in this very interesting space, and the companies here are very different. The mindset from Bay Area is very, very different. The companies are, when you look at companies such as GM, Ford, FCA, they're all either almost 100 years old or more than 100 years old. In Bay Area, an old company is like 10 years old. And so companies move a lot slower here, and things are changing, and you have to change. And so I think that there's a great value in having a group such as ours here, because we're so mobile and we can easily change. And then we're in Detroit, so we are where the automakers, at least in North America, are, except for Tesla. But the big ones, they are here. And so a group such as ours, we can innovate and we can come up with concepts and we can test them out. And so I see this as our next step. And what we're trying to do is we're trying to get engaged with some of these companies such as GM, Ford, Chrysler, so that we can also try to build some of these synergies between them as well. And I think, it's not about becoming the next Silicon Valley or not, but it's finding what you're good at, and Detroit kind of has to refine that, what we're good at. But it's going to take some outside the box thinking, and I feel like that's what our group does. We think outside the box. I mean, all right, we can't afford a full-size vehicle to play with some of this technology, play some of these sensors. We went and bought a smaller RC car, bought some same sensors that work on the same principles, but they're much cheaper. And then we started developing algorithms. And so I think that is thinking outside the box. And then we found the DIY robocars community, and we asked to join it because it's a global community in more than 15 countries with more than 10,000 people. And people there, they're all tinkerers, they're all DIYers, but they like to come up with new ways to do things, and they think outside the box, and they're all over the world. So we are connecting kind of in that way. It's like a global think tank almost. And actually recently Amazon announced that they developed a similar car with their Deep Racer. And it started with DIY robocars, showed them what the value is and how it can be done. And so now they're thinking about creating a global league and rolling it all out. Right now you can only pre-order the cars, but when such a big company such as Amazon is also finding value in this type of approach, I think they're doing it more I don't work for Amazon, so I can't speak on their behalf of why they're doing this. But if I had to guess, try to get people into AI and kind of democratize technology again, and then break down some of those barriers where everyone says AI is this black box science, which, some of it is, but then we created it. At the end of the day, there's algorithms, there's differential equations, there's linear algebra, there's statistics that are behind it, and someone did make it work. And so we want to have presence here in the automotive capital of at least North America, and at some points it was the automotive capital of the world, where these changes are taking place, and we want to help that growth, and we want to help that change, and we want to promote it and then make it easier, and then also show that there is innovation happening here, and there are other people thinking outside the box also in Detroit area. And so it's a multifold of what our group stands for and kind of what we're trying to do and accomplish and how we're trying to accomplish it. But I think that it's important to build a community around this and then continue to innovate through much cheaper centers, but all the same principles, and to allow people to join.
Fascinating. So when you talk about Detroit having 100 years old plus companies, that kind of, I can relate to that. This is exactly how Munich is. And if I may call Munich the European capital of automotive. You mentioned a lot of fascinating points. So one point was softwareization of cars. So you come from Silicon Valley and Detroit. This is a total different mindset. I can relate to that being here in Munich. The BMW autonomous campus is not far from our office. This is where they test drive their cars. So softwareization of cars is taking place. However, this agility, the mobility, the fast-paced Silicon Valley environment is still not there. Yeah. So you're collaborating with the OEMs in Detroit. How are they perceiving it? So and another point to add here, Google just ordered 62,000 Chrysler 20,000 SUVs from Jaguar. So they will softwareize with their stack. Yeah. Do you have long-term visions to also roll your stack to real vehicle?
Maybe if it happens one day, then it does. But I think that I see a bigger value in building more of a community and then getting people to innovate on a smaller scale where it can happen faster, and then you can roll it out, and then value in kind of creating that playground where people can test things and not reap the benefits of crashing a real car. We crash a car, no big deal, at the most you're $200 out. At some point, yeah, I see some of it maybe crossing over a full stack, probably not, because you can't take it from an RC car. But then if we go onto a real car, then at that point, it might as well start our own company. And so here what we're doing is providing people the skill set to take it to the next level and maybe go to one of these companies and then work on their cars there. But here we work on the smaller robotics. And then also these applications, they're not only cars, they're planes, they're washing machines, they're dishwashers, any mechatronic system, which basically, it's sense, think, act. And so you have a sensor, you have an ECU, and then you have a actuator or a servo. And so my goal today is, there's some projects we did. We recently were one of the winners for the ARM Autonomous Robot Challenge, which was a global contest that the company ARM put out. And we won Best Use of AI and Best Social Media Video. But there we're looking at some of the applications that we could do maybe on the commercial side. But in terms of the group, I honestly see it just kind of growing the way that it's growing. Kind of let it be organically. We operate out of a maker space, and in Detroit, it's in Ferndale, which is about 5 minutes from the Detroit city line. And staying flexible and not, filing for a 501c3 or becoming a legal entity, it allows us flexibility. We don't have to report. There's no really investors that we have to answer to. We just do what we want at the pace that we want to do it at. And so it's all up to people, and it's about encouraging the people to use this technology. I mean, we've seen how technology has changed the world, from the automobile to the internet. We want to encourage people, and then as the interest and some of it becomes really, really difficult and really complex, and it's easy to get discouraged and just kind of stop. And so we want to provide a community where it becomes fun. And so learning is fun, and then getting into technology is fun, and we're building and working on fun projects where we want to encourage and reward people for doing these things. And so as far as getting a full stack on a car, I think that there could be some potential there in getting it, but I would say that the focus here is to try to grow the community so people can continue to learn and then go and then put their stacks or start their own startup, which we did have. We helped the startup. It's Passenger.ai. The guy moved to Toronto because there's more machine learning and computer vision based research going on at the University of Toronto. So it's easier for him to get the talent that he's looking for. But we did help him build his first prototype, which got him the funding that he was looking for. And so we kind of try to enable people and give them the tools that they need to take that next step of putting a stack in a vehicle.
I totally agree with you. This is the fundamental difference between traditional industry and software. So most of the commercial softwares that you see today that is in operation, most of them, in my opinion, started open source. You have taken an initiative, you're building something, and who knows, one day this could be the democratization of this could be something like this could be the market leader, because we've seen how the power of community. You also talked about that you're buying a LiDAR and a camera from the market. And as you've seen in the last 10 years, the price of these things dropping exponentially, and it's going to go down and down. So I think this is going to enable even more. Do you have any open source libraries that somebody can download and play with? Can you tell us a little bit about that?
So we started out with the nanodegree library. So, I mean, it's Python, like OpenCV is some of it. And then we developed some of our own software where we try to detect lanes. And so you can go and download a lot of it and then see how we try to port the Udacity code and then try to put it in our own cars. So using algorithms such as canny edge detection, Hoff transforms, and some of it we've been successful with, and then some of it we weren't so much, and it gets pretty bulky. And then we try to use off-the-shelf libraries, and then how we utilize them is where we try to come up with new innovative ways. Is what we do with them. How do we use an RGB space to detect colors? Do we use a lab space to detect colors? And those are some of the things we're working with and playing with. Today, the cars that we have running that's an OpenMV car. So that was put together by the founder of OpenMV Quab, and underneath it is C code that is precompiled, and then it goes on to the OpenMV, and then he uses MicroPython to call out some of those libraries. And then so there is blob detection, which I think blob detection is not something that he invented. That was invented by researchers. And so you can use that to detect basically blobs, depending on what you're looking for. But in the end, it's looking for colors, and then it follows that color, the little car, and it goes. And then also the guys in the Bay Area, they created the donkey car, and that uses TensorFlow, and it's also in Python, and it's behavior cloning. So we try to utilize some of those, and then we try to modify them. So we'll do our training slightly different. And then some of our, we try to implement a LiDAR, which is an ST LiDAR. It's like a $5 LiDAR. I think it's like a 1 or 2 channel LiDAR. So it's not what you would get for thousands of dollars, but you don't need the 64, 128 channel LiDAR
Absolutely.
to proof of concept. And so some of that software, we've put it together, and then we haven't released all of it, but it will go up on GitHub as well, and then you'll be able to find links to it. And so there's also so the libraries we don't build so much ourselves. It's more like what we do with those libraries and what components we get out of those libraries and how we use them and how we put it all together. That's we're trying to find new approaches to use what already is out there in a different way.
You will put some of those work in the GitHub. It's not there yet, and you're not building a library. You're using the existing libraries.
For now, we are, and we're trying to see how far we can go with them. And then also we're building a Blue Donkey, which is it runs on a BeagleBone board, and that software right now lives on. Actually, it is on GitHub, and you can also download it. And then there's their custom drivers. We're trying out different cameras, because USB cameras, MIPI cameras, different protocols, they also play a role in the frame rates. And so that you can go and find on GitHub of, well, it's the Blue Donkey, and if you Google like Jason Kridner and his GitHub repo, or I can send you a link. It's not all cleaned up right now because it's still in the development phase. We have gotten the car to work, but then the next thing, there's a difference between getting something to work and then making it so that the world can use it and making it easy for people to use. At the end of the day, we want to create a product where right now a lot of people are using the Raspberry Pi. We want to give another option. And so we don't want to replace anything. We just want to give more options so we're using a BeagleBone Blue, and some might say that is better for real-time robotics because it has programmable real-time units. It has GPS capability. It has an IMU right on it, and it's a little bit better suited. It has LEDs to tell you the state of your robot right away, and some of those libraries and some of that software is already available and there. But then again, we're using some of the, we're using HOF transforms, we're using RGB color space to detect lines and detect the difference between the colors and then try to follow that edge. And then we use some of the centering algorithms, and that software is also available on GitHub. And right now we're working on a website that we're trying to centralize everything so you can go to one place and then find so that you don't have to go and kind of search through our repositories and find this code, but you can just go one-stop shop. Actually, I have to go through that later today. We have a website, but it's just not, it needs to be a little bit cleaning up so that it's easier for people to find all our software and all the projects that we work on. There's also another software, like for example, for the ARM Autonomous Challenge, there we use the Deep Drive neural network from NVIDIA to drive the car, and then we used YOLO to start out with to recognize sick plants. And the point of the robot there, so we called it the Farm Aid Bot, and its objective is we try to build a Roomba for greenhouses. So it'll deploy itself, go around, find sick plants, and then send you a text message of what's wrong with the plant and what are the possible remedies. What do you do next? And we're trying to work on the next phase robot as well. But the software we used there, so there was similar to Donkey Car. So we trained it to drive around a greenhouse, and then we used YOLO for object recognition training, and that software is also available. And you can find all that on hackster.io, and you can try to build one yourself. It's not super easy, but you can do it. And so we're constantly trying to modify it, and then we're looking at some Octawave now approaches, so that it's basically transponders that we would put around the greenhouse, and then it would locate. But that software is not ready. But the current software, so a modified version of the neural nets and object detection, they can be found, and they're up there. And again, there we started out with something off the shelf like YOLO, and then what the Donkey Car folks are doing, and then we modified it for our needs, but the application was completely new.
Awesome. So how do you collect your training data if you want to train your machine learning algorithm and stuff? Do you collect any data? We've seen companies, startup companies giving away the app. In Silicon Valley, these things happen. People who are using it were collecting the data. What's your thought on that?
So we partnered up with some of the greenhouses locally, mainly around the Ann Arbor area. And we asked them to send us some data. We crowdsourced some of it we found online, and then some of it. Our best approach was actually taking a video, going through the greenhouses, taking a video, and then splitting it up into images. And then that way we can quickly, there were high quality video, it was high quality video, and then we split it up into images, and we used that to train our net using those images.
Gotcha. So fascinating. Now, I have one technical question. So you build a toy car that's autonomous. You detect the lanes. You mentioned you use Kenny Edge or that kind of algorithm. Can you tell us a little bit about it? How do you transform the image information to reality? This is the challenge we face in practice.
Yes. Yeah, so we've been looking at that. There's approaches SLAM, right? So you try to go with simultaneous localization and mapping, and there are different ways to try to localize based on GPS, try to localize based on the images. So the approach is, after doing some research, we were not so successful with the current algorithms that just based on software and like video only and without any modifications to the space. But what we have been more successful, and actually you can see it in Boston Dynamics videos also, is April tags. And funny enough, April tags, the inventor of April tags were invented at U of M, and he's also the co-founder of U of M. And May, if you ever have you heard of a company called Mameability by chance?
No, I haven't.
That's a startup out of Detroit. And
Mhm.
actually, it's interesting because they are the first, as far as I know, in the world to deploy self-driving cars on public roads. They have now signed multiple contracts in other cities. So they are deployed in Detroit, where Quicken Loans employees can use their shuttle services to go from a parking structure to the office. They've also deployed in Columbus, Ohio recently, where anybody can actually go and use their services. And I think they're also scheduled to deploy in Rhode Island and Grand Rapids, Michigan. But anyway, the point is, so we have some access to the founder of April tags. And April tags are basically, I'm generalizing a little bit here, but it's like a QR code, but without the three dots around the corners, but it's a combination of black and white. And so you can use those to localize. And if you watch those Boston Dynamic videos, especially one where the robot runs up the stairs and jumps, some of the videos show, you can see on the floor that they use QR tags to tell the robot that, I don't know their algorithms, but I'm guessing that's what they use to tell the robot to jump. So we've been looking into using those April tags to localize the robot in the greenhouse, and then the OctaWave technology. So like a transponder, you triangulate basically.
Mm.
And we've gotten it to work, and now we're refining it further because it doesn't work well enough. And so that's why for the proof of concept and for the challenge, we use behavior cloning to drive the robot around, then push the data, and then generate a neural net that we can convolute CNN to put on the robot. But some of the approaches that we're looking at now is ideally, like Roomba creates a LiDAR image. And then obviously we're also looking at LiDAR. So we also recreated an image, but we want to have something. Ideally, you would drop it off and it wouldn't even have to create a map. It would just go and know where it is. So you take a vehicle. It's tough, but like, because right now we also rely on maps, right? Google deploys all these vehicles and all these. Now they have people walking around with backpacks that have LiDARs and cameras on them that are creating all these images. And there are a lot of startups that are doing high definition maps that are getting funded. And we're trying to see if that can be a way to localize vehicles. And our approach, we're trying to localize it in a slightly smaller space. So we're looking at April tags and these octawaves.
Fascinating.
Transponder. So triangulation there.
Looking at the number, when Google orders 62,000 Chrysler and 20,000 SUVs from Jaguar, this is not a number that looks like they're going for tests, right? Their autonomous vehicle will be on the road. So you are working with the technology and you see so many difficulties. The car that I drive, when I put the cruise control, lane assistant, at one point if it snows and everything gets disabled, right? So do you think the industry is moving a little premature in terms of safety probably?
Yeah, that's an interesting question. Well, I think the approach that we're currently taking with companies such as Mameability, such as Voyage, such as even Waymo, we're not deploying fully. We're not saying that there is a self-driving car that's ready to take you from anywhere to anywhere under all conditions, but you can see that we're taking it in steps. So Voyage, for example, they're deploying in elderly people communities. So it's there's a set of road. It's not the entire world. It's not super big, and they're traveling predefined paths basically. And so they can create a map and then they can move. And so I think the approach we're taking it is a slow one and it's the correct one. And so I think to say that, oh, autonomous vehicles are going to be there, I think they're already here. It's just what scale are we talking about? And of course there are safety concerns, but at the end of the day, I believe that if you look at, California vehicle reports and, per mile driven and number of accidents, they're much safer than human drivers. And I think we're moving. I think this is a natural course of change. There's going to be doubters, there's going to be optimists, and the people, there's great value in it, and so it'll keep going. And some of the technology, now we're seeing the emergence of radar, for example. There's new frequency bands that are being reserved for automotive use, such as the one from 77 to 81. And with this higher frequency band, the accuracy is supposed to go up. And we're possibly, if you apply some, classification methods, so it's called machine learning and possibly sparse coding, where you can run on an embedded system, and then maybe you can make out an object that from radar data. And radar is a lot less susceptible to weather. And even,
Absolutely.
there's companies saying 4D radar, and the 4D radar meaning 3 dimensions, X, Y, Z, and then speed. And so I know there's a Russian company, Cognitive Pilot, who came here to Detroit about a month ago to talk about it and show their technology. There's another company that recently I read about that is talking about a 4D radar. And I'm seeing a little bit of a shift toward the radar technology. Although, everything is still up for debate because there's no one car, but those, we see 3 main sensors on every car: radar, lidar, and camera. And so how do you fuse that data? But I'm seeing a little bit more of radar kind of becoming a more important sensor on a vehicle.
I agree.
It's already safer. It's just that we're not deploying everywhere all the time. Not every car sold is a fully autonomous vehicle. And then also it's interesting to see, like GM with Cruise, and there's a Cadillac CT6. They use pre-built maps, and then they drive down those and can only do highways and travel down highways, and then it asks you to take over. I'm very curious what the new update on the Tesla and how it's working. I know they just released their next version of Autopilot, and I'd be very curious to hear how that's doing, because apparently it's supposed to be able to go through traffic, pass cars, stop at lights, and so it's getting much closer. But I know Tesla has had their share of struggles. And they rely heavily on cameras, which I don't know how they're going to do with under various weather conditions. I mean, also I've talked to some companies, there's various ways to clean off sensors. There's some are using piezoelectric, so to push air, and then they can couple that with a little bit of water over the sensor, and then they can blow the water basically off the camera and then clean the camera that way. So I think it's getting there. There's definitely some technology, some challenges still to go, but I think it's and that's another great reason why I think it's important for some of these companies to have a presence in Detroit, where we deal with all weather all the time. Rain, sleet, snow, potholes, objects that are covered that you still need to see. And so I think that's part of the reason why Waymo moved out here. But that only happened, I think last year. They're still yet to test their cars. I talked to one of the guys out here in the summer, and they're going to really start testing this winter their vehicles. And so that'll be interesting to see how that goes. And then maybe some new sensors will come out of that testing. Who knows? Or maybe new algorithms, or maybe the emergence of radar, But I think that we're getting there slowly, which is the right approach.
I couldn't agree with you more. You said that this is already safer. So I was talking to someone the other day and talking about some statistics that in the US, 30% of the fatalities that happen with vehicles are somehow related to alcohol consumption. So tell you what, I mean, this is an obvious one. Software is not going to drunk drive, I mean, there's some obvious. It's definitely going to take the fatalities down. No doubt about it. I totally agree with you. So the American roads and the European roads, they're fundamentally different. Your roads are much, much wider. A lot of experts have an opinion that it's more challenging to deploy such things in Europe. How do you see that?
I think it's challenging in both, to be honest. I think it's challenging. We're not ready to deploy on any road in the US because, we have to have these high definition maps right now, which San Francisco, for example, is highly mapped. There's so many startups. In fact, one of my coworkers went there like last week, and as soon as he got off the plane, his iPhone notified him that he's now using high definition maps. And that's like a first. I've never seen that before. And so Europe is, I think, having worked for German companies, they're, especially Germany, they're a lot more conservative. So it's like you're saying, Munich, older companies. So they're going to be more skeptical for a longer period of time. And so Silicon Valley is built on like fast startups, fast pace. So that's why we're probably seeing some of the technologies being more ready. But what I find interesting in this is that out of all the places, right, you don't see that many autonomous vehicles being deployed in San Francisco, like already driving all over on the streets. You hear a lot about cities such as Pittsburgh. Here in Detroit, we have Navia is running on the North Campus of University of Michigan. We have May Mobility. We have some of the other cities. There are vehicles going around the street, test vehicles. But in terms of full-on deployed vehicles in San Francisco, there's not as many as you would expect considering that. And so I think that in Europe, yeah, the roads are different, but it's a matter of finding those algorithms. If we're looking for lanes are still lanes there. And then maybe some of it, like we went to a conference, Intersect 18, down in Knoxville, Tennessee, to talk about infrastructure and how the cities. And, one of my high school classmates, he works for AT&T. And yesterday he actually announced that AT&T is going to start rolling out 5G. And I don't know if you heard that. They're ready. It's starting. So I don't know which cities are first, but that's where if we build connected infrastructure, then it can. But I think more of the issue is how likely is Europe to begin to adopt new technologies? That's what's going to really play a big role, and whether it's going to be ready or not. Like, I think France is actually considered one of the leaders in autonomous driving. And so if you look at that country versus Germany, then it's hard to generalize the entire Europe. I think Switzerland had been trying autonomous cars a long time ago with where they had sensors going along the roads, and the cars were able to navigate themselves, going back like 10 years, I think, at least 10, 15. But that's a really expensive solution. I think the countries with the least conservative mindset will probably be the first to deploy, which kind of brings back to San Francisco. Yeah. And then the rest will follow, and then Europe will be just, I think certain cities in Europe will be slower, just more of the mindset of the conservative mindset. They want to see more miles, more proven technologies before they're willing to put them on their own streets.
I totally agree with you that in Germany we're more slower to accept technologies. However, when it comes to autonomous vehicle, as you know, Germany has several world-class OEMs, and they're pretty ambitious about it. The technology is there, and also German government is also funding building autonomous lanes in our highways. That is going to be an enabler when we have the fully autonomous lanes and we have some autonomous vehicles. So that will also be an enabler for people to try that out. So
news. I know that BMW partnered with Chrysler FCA in North America to develop autonomous cars. And German technology, if you look at a car today, it's, Bosch, Continental. I think that almost plays in favor of Europe and Germany specifically, that they will have more redundancies and more fail-safe improved technology to roll out first. And I think Audi, level 3 they're at now, the Audi A8, the first vehicle to roll out. And so recently,
I guess so, yeah.
That'll be interesting. But I think that car sells mostly in North America.
Yeah, and also technology-wise, Germany kind of drives the safety community, the functional safety community. Yeah, Hans-Leo Ross, one of the safety legend, was in my podcast the other day, and what he said that safety will be the enabler for autonomous vehicle, because unless you can make it safe, you can really deploy safety in the right way, you're not going to win the public confidence. It doesn't make any sense. So in that way, if we can really drive safety, security, and autonomous development together, certainly there will be deployment.
It'll be interesting to see like what approach Germany takes, and so things change. Maybe they'll be the first to do it on a much larger scale. Maybe they'll find a really safe way that's been tested a lot. And now with simulators, you cannot have the simulator as your end result, but you can do a lot more in the virtual space before you ever put it out in the physical world. And so
Right.
you learn to utilize those tools better. You see a lot of those startups as well that are offering different scenarios to test autonomous vehicles on simulators.
Absolutely. So I have two more questions. One is if you would tell our audience to try out the things you've done in your Detroit autonomous vehicle group. Can you give us a pointer, or if you send me the links, we will also put that link in the video.
Sure. I would say, if you are inclined to do so, I would highly recommend trying out using a BeagleBone and a BeagleBone Blue to build your robot and to see if you can speed up the computing power. So like one of the things that also has H bridges right on motor drivers, so it's a little bit easier to connect motors directly to the board, and see if you can make what you can do with it. What kind of innovative sensors you can add, and then most importantly, what kind of algorithms can you to make the system more robust and to make the system better. I mean, like after here, I'm gonna gotta go work a little bit on our Blue Donkey to make it a little bit better. And so I can share the links with you, and then as people have questions, then I'll gladly help out and try to guide them in that direction. And then also, you're more than welcome to take the software and development and some of the object detection algorithms that we use for the Hackster project and try to maybe build your own, little robot that can navigate. And come check our website for updates, and then we'll be posting some of our code with the SD LiDAR that we used. And it's a 2-channel LiDAR, but you can try it out, do some simple object detection at least. And then also, it's a plug for DIY robocars, but the community also tries out different sensors, and they like to post there. Actually, Chris Anderson tries to play with different sensors, and some of the useful information can be found there as well. He does reviews. So, like an RP1 LiDAR or RP2 LiDAR you can buy it's a spinning LiDAR, so it's not stationary. Our LiDAR is stationary, so you can get that code and use that. Or if you want to join the robocar community and then try some of those sensors. Chris Anderson, who used to be the chief editor for the Wired magazine, he sometimes does reviews as well. And so he really enjoys LiDARs, and he's tried out 2 or 3 LiDARs, and you can read up on it. And then some of the code is also available there, and there's links already there for that. So I would highly encourage you to try it out, see what you can do.
Awesome. Thank you very much. My last question to you. So you are building a LiDAR-based, camera-based, autonomous software stack, and there is definitely a gap to that you have to bridge to put it in the real car. How big is that gap? What are the hurdles? What are the things that you have to do?
I think scalability. So the biggest one is, so if you take like an RP1 or RP2 LiDAR, there's the number of channels is going to be a big difference. So how much data you have to process. So we're able to run on a Raspberry Pi, whereas you're going to have much more data coming in on a bigger LiDAR, such as a Velodyne with 64 channels, And so I think just learning. So one big thing I would say is here we're using Raspberry Pis, we're using Beagle boards, and so you're going to have to, there you're going to probably use some sort of NVIDIA. Today, NVIDIA is one of the more popular boards, and so you're going to have to learn CUDA and that how to use the NVIDIA board. So I would say that's almost the biggest difference. Some people in the group are using the same LiDARs and they're putting them on the Jetson TX2. And it's, you know, on that board, you have to learn CUDA. You have to learn, sometimes if you're using custom cameras, you have to write your own drivers. So that whole robotics experience and interface, but you're gonna have that idea already coming from what you're gonna learn in our group on these smaller scale robots. But yeah, you're gonna have to change the drivers, you're gonna have to change the firmware, but you should be able to do that because you have an understanding. Yeah, it'll take some time, but you'll already know that, all right, maybe it's the firmware I need to rewrite, maybe it's the driver. Communication protocol sometimes can change. You know, sometimes you'll be sending data on CAN, sometimes you'll be sending data on Ethernet, sometimes you'll be sending data on I2C. And so those are some of the challenges that I think you'll have to come across. But that's where we think that because you get engaged in this community, you'll be able to tackle them because you'll know to look for them and you'll know that they exist. And so, yes, you will have to learn more. You'll have to build bigger matrices. You will need more computing power to solve these issues. But the approaches in both cases, for example, you'll be doing a Hoff-Lane transform.
So if I understood you right, scalability, computation, but there will be more computation needed. That's the first hurdle. Second is the sensors. You probably have to build the drivers. How about the interface between the vehicle and your software?
Yeah, so that's where I think CAN and Ethernet. And so we're right now communicating. The data is, it comes in on a Raspberry Pi. It comes in they use a ribbon, and then it comes up. So you send some MIPI data. In vehicles like at GM, you would be getting through Ethernet, so slightly different protocol. Some of the data comes on CAN, and so also using ROS. That's one thing that I didn't touch upon, but our community is now getting into ROS, robotics operating system, that is able to do data fusion. And so you're going to have to do, I think that is the biggest hurdle that you will go through, is how many sensors do you use? So right now, if you're using only one sensor, it's easy. All the data is time aligned. Everything is on the same playing field, so to speak. But if you start taking a radar, a LiDAR, and then also a camera, and then you have multiple cameras, multiple LiDARs, multiple radars, you have to somehow time align that data and then create an interface of which data is more important. And so there you're going to have to, most people are either using their own proprietary software or they're using ROS, and ROS 2 recently came out. And so data fusion, you're going to have to fuse a lot more data. That's going to be like another critical step. And then on CAN, for example, there's arbitration, so which message is more critical? So if, for example, you have your brake pedal on CAN, on powertrain CAN, and then you have your, let's say, shift transmission. And so if the brake pedal comes in, the arbitration has to be won by the brake pedal. And so figuring out that level of arbitration of which data is more important, and then setting up different networks. So, I think camera data, then there's flex rate, there's Ethernet. And so those protocols, we don't get into them too much with what we're doing on the Raspberry Pi, but that is something you're going to have to also learn. But we use, for example, on the Raspberry Pi, we use I2C, and then that's converted to PWM. And but still here on the vehicle, you also deal with PWM. You also have PID controllers. So that will be very similar. The concepts will be the same. But like you mentioned, interfacing between different modules. Traditionally in automotive, it's been CAN. It's a 2-wire system that runs on 0 to 5 volts with stable state of 2.5 volts. And then you have a voltage differential. And but that's not enough. The bandwidth is not enough. It can't transfer enough data. And so automotive is looking into some of these other solutions. So that is also, for example, the BeagleBone and the BeagleBoard, it does have CAN communication capability, and but we haven't found an effective way to really entice people to use it to make the car go faster. And then, of course, cybersecurity. That's the hot topic of today: is how do you get these messages across securely? And so, how do you make sure that the data was sent out is the same data that was received? And so, I think checksums were used traditionally, and now we need more secure protocols and more secure ways to communicate that data so people can't hack into it. And that's one of the scary things. And we're also looking to get into that. There's a chapter here of the German cybersecurity meetup. And that is something we're exploring right now, how to make that so that it's usable for the cars. And so cybersecurity, for example, you're going to have to learn about that. But I think everybody's kind of struggling right now, trying to kind of sum up what are the things they're going to have to learn as you move on to a larger vehicle. And I think those are going to be computing power. Those are going to be, writing the drivers and firmware to interface software with hardware. Then also some of the communication protocols, they're going to change. It's probably not going to be I2C. It's going to be more like Ethernet or CAN-FD, and cybersecurity, of course. So I try to encourage people to get involved in this. So I think that, especially AI, and it's really cool that Amazon did what they did with releasing their Deep Racer, which I would encourage as many people all around the world to get involved in the community and then try to build something yourself and get out there. I think also the great value of the community is not only you're going to learn these technologies, but also you can speak a common language. So for example, when I went to Germany for work, I found some of these meetups that are part of our community, and the community is DIY Robocars. And I was able to go there and find a common language right away. So it's not just about technology, it's also about building relationships and having something to talk about and making friends where you otherwise would have never made those friends. And so you can, it's very cheap to get involved. And so you can do everything from learning the highest paying technologies today to finding friends around the world. And so I'd love to encourage people to get involved, get going, build stuff. And I mean, at the end of the world, for now, at least, we're still living in a physical world where we're governed by physical objects still. It's becoming more and more virtual, but not there quite yet.
All right. So Alex, thank you very much. This was really, really fascinating. Thank you very much for watching. If you have questions and comments, please write below. You can also write me an email, podcast@matrickz.de. Do you have similar projects? Do you have similar experience? Please share with us. Please write in the comment section. Would you like to get involved? Would you like to know more about this community? We'd love to hear from you. Thank you again for watching.
In this podcast show, we bring in the industry leaders and experts in the automotive domain to share their experiences along their journey. The mission of our podcast is to start a dialogue that will allow us to understand the development of automotive industry and where the automotive industry is going. You can ask questions to our guests directly. Just send us an email to podcast@matrickz.de. We'll schedule a call with you during the recording and you'll be part of our show. Make sure you subscribe so that you don't miss any new episodes. Please share this video to help others get enlightened as well, and that would mean a great deal to us. See you in the next episode.